All right, we are in our Zoom class and we are in geometry. We are on our new unit, which means everyone has this unit guide. I will be posting this unit guide to Google Classroom here shortly by the end of class, but you'll notice that there are 10 days for the entire unit. That's 2 weeks. We have 2 quizzes and a test. So, woohoo! Oh my! You may not. I just started my lesson. Dude, you have like 10 minutes to go to the bathroom. And now you want to leave right when I start my lesson? No, thank you. All right. Today is the 7th of March, 2023. We are the Pythagorean Theorem, our new unit. You've already learned how to do this from last semester. We're taking it a little bit further. Is that distracting you? Should I? No. All right. So let's talk about the theorem. You have to have what for the Pythagorean theorem? You guys already know this. Help me out. You have to have a certain type of triangle.
Right triangle.
It has to be a right triangle. So you have to have this giant if. If you have a right triangle, then this works. All right, Israel, you can start taking notes because you're obviously being distracted, right? If you're paying attention, that's okay. If you're talking to each other, that's not okay. Then the following holds true. There's my right angle symbol, and I'm going to have my legs. It doesn't matter where my A and B go. I can interchange those. Those are called legs. If you want some vocab, these things out here, those are called your legs. And then this side that is opposite of the 90-degree angle is called the hypotenuse. And we usually call the hypotenuse C, but you can use any letter that you want. If you have a right triangle and it looks like this, then you will have A squared plus B squared is equal to C squared. Most people originally think that this is only used to find the hypotenuse. Sometimes I will give you the hypotenuse and you have to work backwards to find one of the legs. In this, by the end of this lesson, I'm hoping that I'll be able to give you a right triangle that has square roots already inside of it, and you'll know how to solve for the remaining side. Some of those will take 3 steps. Sometimes it's not as easy as just finding one of the sides. And I'll show you what I mean in a second. So let's do our first example. Example number 1. Let's go ahead and give ourselves this triangle that is, you already know how to work forwards. Let's go ahead and work backwards. What if I know that this is 13 and this is 12 and I don't know that length right there? Go for it, Claire. Set it up.
A squared plus the bottom of 12 squared. So 13.
You said a squared. Can we use x squared instead?
Yeah.
Okay. X squared plus 12 squared is equal to 13 squared. Notice that Claire put the hypotenuse squared on a side all by itself. All right. Someone new. What do I do now? Why raise hand? Come on. You got this, guys. Come on. Thank you, Israel. Yes. How do you do 12 squared? Then sit in the front. No one is sitting in the front. I'm being honest, Israel. If you cannot see, you need to be up here or get glasses. 160. No. 12 squared. 12 times 12. There it is. 144. All right, I'm gonna put my equal to sign. Yes, Sean, thank you.
Oh, it is 169.
That side is 169. In this x squared, I'm not going to do anything. I'm still having x squared plus 144. I'm trying to solve for x. So subtract 1 on both sides. So minus 144, minus 144, Solomon. What is my x squared? Again, 144 is gone. They cancel each other out.
15.
Close.
25.
Yes, there it is.
I thought you were giving me my answer.
And we'll give it to Ashton. He's trying to hide back there.
What?
Now what?
Oh, so now, no, dude, not even try. So now, dude, I don't trust none of y'all, bro. I'm not listening.
No, because you were paying attention, you'll know how to undo a square, right?
Oh, you square rooted.
Okay, so if I square root the left side, I also
Square root the other side.
the other side. And what's the square root of that side?
I don't know.
You don't know the square root of 25?
No.
What times
Five.
1? Oh yeah. That means x is now by itself because those cancel each other out. X equals to 5, and we have the length using the Pythagorean theorem. Woo! Okay. Problems where the answer comes out nice and simple. There's going to be one of those on the quiz, one of those on the test. The rest of them are going to be medium and hard. Let's show a harder example. All right. So example 2.
What? That made me cry. Yeah, man. What?
All right. Example number 2. I have
Wait, this is what we're doing algebra 2, isn't it?
algebra 2.
Yeah.
Pythagorean theorem in algebra 2. We use that to derive special right triangles and trigonometric
Yeah, we
functions.
did ABC. I mean, A squared plus B squared equals.
Yeah, I mean, you use that to derive other things, but
Yeah.
this is a slightly different path. This is the more geometric path. What do I have? The square root of 8 to square root of 3 and x. Dun, dun, dun. Mr. Sindel, they put square roots in it. That's hard. Yeah. How do I deal with that?
Square root, you just do it.
You just do it. Listen to that guy. He knows what he's doing. You just do it. You have an a squared plus b squared is equal to c squared. I'm worried that Zoom kids are now off the board. Can they see? They can see. All right.
It's just like.
What do I plug in for a? Sure. Yeah. Let's put the square root of 8 in for a, and a was being squared. So this cancel. He said, "Oh, it's gonna." He already sees what's about to happen. Nice. All right. I'm gonna copy down this plus sign. Copy down the plus sign. This is my spot for b, and b is going to be squared.
2 square root 3.
2 root 3.
What would you do?
2 squared. Oh yeah, that's a good question.
23.
Good guess, but not quite.
6.
All right, and I'm going to copy down my equal to sign, and now I'm definitely off the board. Sorry, Zoom kids. Yeah. There, now you can see. And here's my spot for c, which is going to be squared. Let's see, who's paying attention? Oh, Sway's paying attention. He knows what goes in this spot. X. All right. So Claire, I mean, Solomon already told you the answer here, Claire. What is this first one going to be? 8, because square root and square root cancel each other out, leaving you with just 8. That's the easier one. This one is tricky. Everyone be paying attention. This is the hardest part of the problem. If I have 2 square root of 3 squared, the square is going to distribute to both of these, and I'm going to get 2 squared square root of 3 squared.
Wait, but then it's just 2 squared plus 3.
What's 2 squared?
4.
So you're going to get 4. There's a multiplication symbol in between these. It's going to be 4 times
12.
3.
16.
This turns into 12. I don't know what that happened. Okay, plus sign, going to copy down the plus sign. All right, let's go now. Right side hasn't changed, it's just x squared.
20 equals x squared and then squared.
Oh yeah, he's on the next step. Oh man, Solomon's doing all the heavy lifting. That's 20. All right. Ooh, let's get some of our Zoom kids to pay attention. I don't know. Zoom kids. Yes, Julie. She's trying to hide off the camera. I'm gonna call on her. Julie, what do we do on both sides now, Julie?
Where? Square root.
Yeah, exactly. Square root. X is equal to the square root of 20. Oh, who are we gonna give this problem to? Should we give it to another Zoom kid?
Yeah. Yeah.
All right. All right, we're giving it to Eric and we're gonna see what happens. Eric, how do I reduce that square root of 20? Like I need to do a factor tree, right?
Yeah, I got you.
1 times 1 is 20, Eric?
I'm gonna have to pass this to Riley.
No. You can in a sec, but hold on. You know what times, I'll give you one of them. 1 times 20, but that's not helpful.
20 times 2.
10 times 2.
10 times 2 is a good one. We'll do that one. 10 times 2. We're ready to keep going. We'll give this one to Riley now. Riley, I can go farther with 10.
2 and 5.
2 and 5. Remember, everything has square roots in it, and that's as far as we can go. That's a prime number, that's a prime number, that's a prime number. This was a composite number, which meant it could keep going, but these I can't go any farther. All right, so.
Okay, so you get 2 root 5, right?
So just to remind you guys, I have this square root of 2, this square root of 2, which means my final answer is going to be square root of 2 times square root of 2 times square root of 5. But usually we don't write it like that. Usually we write this as square root of 2 squared, because there's 2 of those terms, times square root of 5. And then finally, we can say that the square root and square cancel each other out. Right? So the final answer is going to be 2 square root of 5.